I have here the equation f of x is equal to negative x cubed plus 2. And I want to know the different transformations that are going to take place, and then I want to graph it. So first we need to figure out what those transformations are. So if we look here, we can see that our base function is x cubed. And also we have an addition of 2, and we also have a minus sign multiplying our base function. So we know that when we have an addition to our base function, we know this is going to be a vertical shift, and more specifically an upward shift of 2. And when we have a minus sign, as we just learned, multiplying our function, that means we're going to have a reflection across the x-axis. So now that we know all of our transformations, all we are left to do is to graph this. So here we have a graph, and it may be helpful to first put up what x cubed looks like, just so we can see a comparison. So let's say we're going to graph x cubed. It's going to start at 0, 0. We put in 1, we get 1. We put in minus 1, we get minus 1. We put in 2, we get 2 times 2 times 2, which is 8, which is going to be off this chart. So it's going to look like something like this. And it's going to eventually hit 8. So it increases very quickly. And if we put in minus 2, we're going to get minus 2 times minus 2 times minus 2, which is minus 8. So that is going to go off of my chart too. So this is what x cubed looks like. Now let's see what our transformations are going to do to this graph. So here we're going to be graphing minus x cubed plus 2. So the first thing we can do is move up our center by 2 units. Because when we put in 0, it's going to be the same as this one, but it's just going to be up 2 units. So that's our first transformation. And then our only other transformation is a reflection across the x-axis. So if we were to look at this graph, and we wanted to say, well, what would it look like if we put a mirror here? Well, this would be reflected over here, so it would look like this. And this would be reflected over to here. So this is being reflected here. So just imagine like you're looking in the mirror. And this would look like this. So again, you have this like chromosome shape almost. So what's going to happen is that we're going to have our point where it's going to go 1, 1 like that, and 1, 1 like that, and then it's going to go off the charts both times. We're going to get something like that. Like that. So this is what our graph looks like. It's up to, and it's been reflected across the x-axis. So now I want to move on to one that is going to be a little bit more challenging. So this one is f of x is equal to 4 times the square root of 2 minus x. And I want to graph this. So the first thing we're going to have to do is look at the transformations. We can see that there is a transformation here where we have 4 being multiplied by our base function, which is the square root of x. So our base function is the square root of x. But also we have a minus sign here. So a minus sign, and we have 2. So we also have a constant being added to an x. So what we need to do is sort out what all of our transformations are going to be doing. So let's start with this 4. This 4 is pretty easy. We're multiplying our function by a number that is not a fraction. So this is going, and this is not inside of, it's not multiplying the x. This is multiplying the entire function. So this is going to be a vertical. So this is going to be a vertical stretch. So a full stretch of 4. Next we can move into the radical. So let me rewrite this radical and forget about the 4. So the next thing to sort out is what is going on under this radical. And when people would look at this for the first time, I wouldn't be surprised if most people got this wrong. Most people would probably come in here and say, okay, well we have reflection across the y-axis because we have a minus times an x. That's in a that's being like a minus x being substituted in. So they'd say reflection of y, and then we have people would say, well, we have a plus 2 here, so that would mean we would have a horizontal shift, and that it would be a horizontal shift of 2 units. But but if you said this, you would be wrong. So these are wrong. Well, we'll see why in a second. Well, not this one. This isn't wrong, but this would be wrong. And that's because when we are looking for horizontal changes, as in shifts, they're in the form of x minus a. So that means that if a is a positive number, that means we would be shifting to the left. But here, because you have to remember, it's a minus a. If it's a negative number, that means we shift to the right. But here, it's not in that form. This is negative x. This is a negative x, so it's the opposite. So one helpful way to sort out this problem would be to think of it like this. Minus x minus 2. So if we distribute this x, we get the same thing. And we still have this reflection across the y-axis. But, as you notice, we have a minus 2 instead. Because this is not in the same form as this. So the rules will not be exactly the same. It has to be in this form, unless you can just say, well, it's a minus sign, so it'll be the opposite. But a lot of people aren't going to see that, so I recommend just changing the form, like this. So you have a positive x. So now we have a positive x. We still have our negative sign multiplying our x. But we can now clearly see that this is going to be a shift to the right, not to the left. So now let's write out what else we've sorted out. We've got a right shift 2 units, and then we have reflection across the y-axis. So now let us graph this now that we have all of our information. So I'll draw a real quick graph of the square root of x, which looks like this. We start at 0, we have 1, 1, and when we have 4, 2. And it looks just like, that's close enough. So it looks just like that. Now over here, we're going to have the graph y is equal to the 4 times the square root of 2 minus x. So remember, we had a vertical stretching of 4. We had a shift to the right of 2. Because remember, when we pull out this minus sign, this becomes x minus 2. Or unless you notice that it's a minus x, you can reverse the rules. But to simplify it, if you're having trouble with it, just pull out the minus sign, You still have that minus sign causing the reflection, but you can see that it would be x minus 2. A minus parentheses x minus 2. So it's easier to see that there is a shift to the right of 2 units. And then we have reflection on the y-axis. So now let's start. We had our shift to the right 2 units here. It's going to be reflected across the y-axis, so it's going to come over this way instead of going this way. So we're going to go up 1 and over 1 like we would in this graph. But also we have a vertical stretching of 4. So instead of 1, 1, we're going to have 1, 4. Like that. And when we get 4 units over, 1, 2, 3, 4, ordinarily we'd have 2. But instead of 2, we'd have 8, which is all the way off of this chart. So we go, it's going to come up like this. Well, that's not very good. So over here, it'd be off the chart by here. So like that. And this is a really terrible graph, but I can't draw any better. I'll try, but it doesn't seem I'm getting any better. So anyways, let's review. Man, this graph is just so terrible. I just can't allow that. It's something like, yeah, something like that. Where we can see that it's being reflected across this way. It's being reflected across the y-axis. We had a shift of 2 units to the right, and then we have a vertical stretching of 4.